Alright, factoring polynomials. Some of this is review, some of this is new. Alright, so the first one. This one is a review. This is a review part. Let's zoom in a little bit. I don't know what size screens you guys are looking at. Oh, here we go. So, some people are still having difficulties with this, but most of you got this. Those people who are having some difficulties, here's a way to organize your information. Right, the way you organize your information. So you got negative 30. You're going to put that in the top of this little x, and you're going to put negative 7 in the bottom of this little x. And what you're doing here is saying, what are the factors of negative 30 that combine to make negative 7? So like negative 10 times 3. Negative 10 times 3 is make negative 30. Negative 10 plus 3 is negative 7. And you put the factors that work in these little spots. And then it's just x minus 10, x plus 3. And that's your answer. That means this x minus 10 times x plus 3 will give me x squared minus 7x minus 3. 30. Alright, and that's it. That's the answer. So this is the factored form of that. This is the factored form of that. Alright. This one, and a lot of you are still having problems with this. Same basic technique. Put a little x. This is the way we organize our information. Except the top number is going to be the product of 3, the front number, and the last number, negative 20. So that's negative 60. Right? You get that from doing 3 times negative 20. Right? The front number times the last number. Leading coefficient times the constant. And the bottom number is still the middle number. So we put negative 7 there. So what are the factors of negative 60 that combine to make negative 7? That would be negative 12 times 5. Now, if some of you are wondering how I come up with these, well, one, it's experience, or two, trial and error, right? You can look at negative 60. And if you have a hard time just trying and guessing, you can do it systematically. What do I mean by that? Well, to get negative 60, you do negative 1 times 60. Well, that's going to be combined to make 59. It's too far away. And then just go up from there. Negative 2 and 30, negative 3 and 20, negative 4 and what's that, 15, negative 5 and 12, negative 6 and 10, so on and so forth. Okay, 7 doesn't, 8 doesn't, and you're back to 10. And if you come back to yourself, then stop. Right? Or if you have an idea, like negative 1 and 60 are just too far apart to get negative 7, and skip some of these. Just skip some of these. Jump to like 15. Right? Negative 4 plus 15 makes 11, so that one's closer, and then try the next one. So if the first one you guess is too far away from a number, you can skip a couple of these to get something that's closer to what you want, right? Which is negative 7 in this case. But once you get practice this, then this becomes a whole lot easier. All right, let's move on. So here, now that I've chosen my negative 12 times 5 gives me negative 60, and negative 12 plus 5 gives me negative 7, I have my numbers. And this is the Lizzie method. We're going to go ahead and just write x minus 12, but we're going to divide it by the leading coefficient. We're going to divide it by 3. And x plus 5 over 3. And you must reduce if you can, so it's x minus 4. If you cannot reduce, go ahead and bring the 3 forward, so it's 3x plus 5. And that's the final answer. That's the final answer. All right. Now I'm going to go to this box here, because this is not new. We've done this before. Right? A squared minus b squared. So it's a perfect square minus a perfect square. The factored form looks like this. Square root plus square root minus square root. Okay? So here's an example. Let's say I have x squared minus 9. That would be equal, right? X squared. What makes a something with an exponent a perfect square? And the exponent is an even number, makes that a perfect square. So square root of x squared is x. So it's x and x. And then square root of 9 is 3. 3 and 3. And you put the plus and the minus. Order doesn't matter, by the way. If you put x minus 3 first and then x plus 3, that's perfectly okay. Alright, let's do another one. Let's do 4x squared minus 25. 4 is a perfect square, and x squared is a perfect square. So that becomes 2x and 2x. And 25 is a perfect square. 5 and 5. 1 is plus, 1 is minus. Okay. Now be careful. If I have something like x squared plus 25, this cannot be factored. Not factorable. Right? This is the difference of two squares, not sum of two squares. This is a sum. So notice the difference always has a minus sign in there. Right? So this one is not factorable. Alright. This is the new technique, grouping method. Okay? You're going to use this when you have 4 or more. And it's got to be an even number. Like you can do a group of 4, or you can do a group of 6, or a group of 8. Well, we're probably going to just stick with groups of 4. Okay. Now be careful though. This is a very concocted problem. Okay. I mean, I guess all of these are. But sometimes you can do it. And then this week, if I give you a polynomial with 4 terms, this week and next week you'll be able to factor it using this technique. Okay. Later on, we'll be visiting other techniques. But for this case, you can do this by grouping. So you're going to group these two and group these two. So that's what the grouping means. That's why it's got to have an even number of terms. So you can have an even grouping, right? 2 terms here, 2 terms here. And what you're going to look for is a common factor. So what goes into both 6x cubed and 3x squared? Well, 3 goes into both 6 and 3. And you always notice in the front group is always going to have a variable in common. So and you take the lower exponent, so it's 3x squared. So 3x squared comes out. So 6 divided by 3 is 2. If you take x squared out of x cubed, that's going to leave an x. Right? So I've taken 3x squared out of 6x cubed. Now I'm going to take 3x squared out of 3x squared. So that's 3x squared divided by 3x squared. That's 1. Okay? Now, over here, I'm going to take a 4 out. Right? 4 goes into both 8 and 4. So I'm going to take a 4 out. 8 divided by 4 is 2. I didn't do anything with the x, so the x just comes down. 4 divided by 4 is 1. And there you go. Now, look what happened. I got a 2x plus 1 in both of those. If that did not happen, one of 2 things happened. Okay? Either you did something wrong, or 2, you can't do this problem by grouping. For the next couple weeks, that's not going to come up. Okay? So all of these that look like this can be done by grouping. Alright. I'm not going to pull a fast one on you or something. Anyway, what I have here is a 2x plus 1 in common, so I take that out. That's going to leave me 3x squared plus 4. Okay? Now, you should check this one because there's an exponent on this. This might be further factorable, but I have an x squared plus no x. That means it's not factorable, right? It was like similar to this. And 3 is not a perfect square anyway, so this is not factorable. All right. So that's the first new method. These are 2 new methods. Well, really just 1, right? One's called the sum of cubes. The other one's called the difference of cubes, right? So the only difference is one is a sum, and the cubes are, so the a to the third, that's a cube. B to the third, that's a cube, okay? A to the third, that's a cube, minus b to the third, cube, all right? All right. Also at this time, it might be a good idea to list all the perfect cubes that we know, all right? So I'm going to just do that over here on the side. So if I have 1 to the third, that's 1, obviously. 2 to the third, that's 8. So what I want you to do is recognize that 8 is 2 to the third. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. Oops, running off the page there. All right, give you a moment to, yes, write these down in the margin of your notes. 7 to the third is 343. 8 to the third is 512. 9 to the third is 729. All right, and 10 to the third is 1,000. I suggest you pause the video and copy these down. You want these on hand or memorize it, or you could just stare at the screen and memorize it now. All right, but anyway, I'm moving. So if you look down here, you're going to recognize 27. 27 is one of those over here. That's 3 to the third. So I'm going to take this step. You do not have to write this step. All I did was rewrite the 27 as 3 to the third. I am writing this for emphasis, right? So basically I have the left-hand side now. It's x cubed plus 3 cubed. My x is a. My 3 is b. So I'm going to rewrite this as x and then 3. I keep that sign. It's plus. Right? So I've rewritten it without the exponents. Now, once you get here, forget what you had. Okay? The trinomial you're going to produce it from the x plus 3. Because look what happens. So here, you go from a to a squared. Right? You're going from a to a squared. So I'm going to take this x and square it. So that's x squared. Change the sign. The plus becomes minus. And then the AB means you multiply a times b. So it's x times 3, or just 3x. And the last term is always a plus. And you just square the second term, right? B squared. So it's 3 squared is 9. And that's the answer, right? So this is the factored form of x cubed plus 27. This is the factored form of x cubed plus 27. Side note, this trinomial that comes out of this x cubed plus 27 cannot be factored. This trinomial cannot be factored. Okay? So that means you can stop. You don't have to check to see, or you don't need to try to factor it. Now, if there's a higher degree, like if this is x to the 4th, then it might be a factor. But if it's just a straightforward cube, then you're safe. You don't have to factor this. Let's go on to the next part. So here, so this is this difference of two cubes. Okay? What is 64? 64 is 4 to the 3rd, and you have x cubed minus, and 343 is over here, is 7 to the 3rd. 7 to the 3rd. So we're going to write 7 to the 3rd. Okay? This one's kind of long, so I'm going to just go write on a separate line. So what's being cubed here is 4x. So it's 4x, keep the sign, minus 7. The 7's being cubed. So this 4x minus 7 is this part of the formula. The a minus b. My a is 4x, and my b is 7 in this problem. And then I'm going to this part. So forget this part, right? So I'm going to produce this trinomial using these terms, the 4x and the 7. Okay? 4x squared, 4x to the 2nd power. So that means you square the 4, which is 16, square the x, that's x squared. Change the sign, so that becomes plus. Multiply 7 times 4x. Now don't trip yourself up thinking that's negative 7 times 4x. Okay? That sign only tells you what to do with this sign. So just do the 7 times 4x. So that's positive 28x. And then square it. Square the 2nd term. 7 squared is 49. And that's it. Okay, now I'm going to go on to the back. Alright. So, looking at this one, we're asked to factor it completely. Is 48 a perfect square? No. Is 48 a perfect cube? No. Not that we should check. Right? That's x to the 2nd power, not x to the 3rd power. So that doesn't do anything anyways. So, what do? Well, look for a common factor. So if it doesn't fit anything, take out a common factor. Right? So here, 3 goes into both of those. 48 divided by 3 is 16. And 75 divided by 3 is 25. Now I have a perfect square minus a perfect square. 16 is a perfect square. Even exponent makes that a perfect square. 25 is a perfect square. So that means I have a difference of two squares. So I take the square root of 16x squared, which is 4x, right? 4 times 4 is 16. X times x is x squared. That's why we can do that. Square root of 25 is 5. And you do plus 5, and then you do the minus 5. And that's the answer to that one. Okay? Part B. That's a perfect cube, right? 1000's a perfect cube. 729's a perfect cube. Remember this? 1000 is 10 cubed. 1000 is 10 cubed. 729 is 9 cubed. So it's 10x minus 9. This is a difference of two cubes. This is a difference of two cubes. So I'm using that form, right? I'm using this form. Let's see if I can make it fit on here. No, I guess I can't. Alright, so I'm using the a minus b. So that's what a 10x minus 9 is. It's the a minus b. Okay? And then I'm going to fill in the second part. It's square the first term. Square the first term. So it's 100x squared. Change the sign from minus to plus. Multiply 9 times 10. So it's 90x. Plus. And then 9 squared is 81. And that's it. right? Remember I said that this trinomial cannot be factored when it comes out of the difference of two cubes, all right? Unless that's a higher exponent. All right, let's go on to C. So this has 4 terms, so it's going to be factoring by grouping. So I'm going to group those two together and group those two together. What's common here? So you're going to have an x cubed, and a 6 goes into both those. 6 goes into both 6 and 24. So it's 6x cubed, and I'm running out of space there. 6x cubed. So if I take 6x cubed out of 6x to the 4th, that leaves me just an x. And negative 24x cubed divided by 6x cubed is minus 4, right? 24 divided by 6 is 4. There's a negative sign. Taking x cubed out of x cubed leaves no x, right? Now, here's a weird part. Okay, this is an important example here. So I have a negative 5x. So whenever this term is negative, it doesn't matter if both of them are negative. If that term is negative, you have to take out a negative. Okay, if that term is negative, you must take out a negative. So that's going to be negative 5 times x. Now, if I take a negative 5 out of positive 20, so it's like positive 20 divided by negative 4 makes negative 4. So that's important here. Okay, so whenever that term is negative, you got to take out a negative number. Doesn't matter if both of them are negative or not. If that one's negative, take out the negative. All right, and then look, I got x minus 4 in common, so I can take that out. X minus 4 and 6x cubed minus 5. Alright, so when I take x minus 4 out of the first group, it leaves me the 6x cubed. When I take x minus 4 out of the second group, it leaves me the minus 5. And that's it. Alright, D. So look, so there's a weird combination of x's there. So there's too many x's. I got to take one of those x's out. Take the x out. That's going to give me 7x squared plus 37x plus 10. Alright, that's what we got. Now we're going to factor that. So that's one of those Lizzie method problems. It's a trinomial with a leading coefficient. So you do 7 times 10 is 70. And you want the middle number, 37. What are the factors of 70 to combine and make 37? Well, 35 times 2, right? 35 times 2 is 70. 35 plus 2 is 37. So let's do that. So this x just come for the ride, right? Don't drop that. So it's going to be x plus 35. Don't forget, put it over the leading coefficient. X plus 2 over 7. Right? Don't forget to put it 7 underneath out of both of them. Right? It's always use leading coefficient. Clean that up. X 35 over 7 is 5. Here, bring forward the 7 plus 2. That's it. That's D. E. We got x to the 4th minus 81. So that's an even exponent, so that's a perfect square. 81 is a perfect square. So that means you can do the difference of two squares. So you got x squared minus 9, x squared plus 9. Right? Half of 4 is 2. That's the square root of x to the 4th. You just half the exponent. When you take the square root of a number, it's normal. Square root of 81 is 9. So it's x squared minus 9, x squared plus 9. But I got bad news. This can be factored further. X squared minus 9 is a difference of two squares again. So it's x minus 3 and x plus 3. But recall, if I have a plus sign, it cannot be factored. So that one's not factorable. So that's it. Alright, moving on. F. X to the 6 minus 1. That's an even exponent, so that's a perfect square. And then there's the 1. 1's a perfect anything. Guess what? It's also a perfect cube, but it's in your best interest to deal with the squares first. So treat it as x cubed minus 1, x cubed plus 1. Right? If it's an even exponent, treat it as a difference of squares first. And now look what we got. This is a difference of two cubes, and that's a sum of two cubes. So we got the sum and difference formula. So using the difference formula first, so it's going to be x minus 1, right? Cube root of x cubed is x. Cube root of 1 is 1. Keep the sign. I'm still working on this one. Go ahead and square that. So it's x squared. Change the sign. Multiply x times 1 is x. Plus 1 squared is 1. So this x cubed minus 1 turns into that as a difference of two cubes. Continuing. Now I'm going to factor x cubed plus 1. This is just a plus version of that. So that becomes x plus 1, right? X plus 1. Square the first term. Change the plus to a minus. 1 times x is x. Plus 1 squared is 1. Oops, can't see that. So that's it. That's this combination is x cubed plus 1. Those two go together. Zoom out a little bit. Alright, there we go. And that's the last example. Good luck. Oh goodness.